humans love to categorize things. We love to take a group of objects and see if we can find any patterns in their similarities and differences. It helps us bring order to the chaos of a large data set. And, well, if you think about it, astronomy deals with some of the largest data sets possible. I mean, there are over 100 million stars in our galaxy alone. If we're talking about the entire universe, well, we barely even have numbers big enough to describe them. So, what are some important things that we want to consider when making our classification system? Well, we need to make sure that our classification system is broad enough that we don't end up with so many tiny categories that we just get overwhelmed. But it also needs to be specific enough that we can actually make some meaningful predictions based upon these categories. Early classification systems were focused mainly on sorting stars based on their color. So we had a category with your white, blue colored stars, your yellow colored stars, and your sort of orangey red stars. Now the problem with that is that there's a lot more to a star than just its color. And so as time went on, we moved, instead of looking at the color of the star, to looking at its spectrum. Now by looking at a star's spectrum, we can actually determine what the star is made of, because different elements emit at different wavelengths. So, by sorting stars according to their spectra, we were actually sorting them based upon what they were made of. Our current classification system consists of 7 main types: O, B, A, F, G, K, and M type stars, with your hottest being your O-type stars and your coolest being your M-type stars. Now you might be wondering why on earth we have settled on this arrangement of letters, like why isn't it in alphabetical order or something? And it's just historical reasons. You see, the original stellar classification logs did attempt to put things in some sort of alphabetical order, but over time we realized that it actually made more sense to classify them in terms of their temperature and their spectral lines, which led us to our current O, B, A, F, G, K, and M.